Okay, so we have our final function here, number 35. Which of the following statements is true of the magnitude of the acceleration of the object at t equals 1 second? So this is based off of the same situation as before. An object is initially hanging in equilibrium from a vertical spring. It's pulled down 15 centimeters from equilibrium position as illustrated above. It's released at time equals 0, and then it oscillates with a period of 2 seconds where x equals 0 is the equilibrium position and the positive direction is upward. So if it wants to know what something about the acceleration of the object at t equals 1 second, we're gonna have to take a couple derivatives, because currently we have the displacement, so we need to take 2 derivatives in order to get the acceleration. So if we have x is equal to negative 0.15 times cosine of pi t, and we want x prime, the derivative of cosine is negative sine, so the derivative of negative 0.15 cosine would be 0.15 sine of pi t times the derivative of the inside function would be pi. So there's our first derivative. Now we want to take the derivative again. So we would have the derivative of sine is cosine. So we would have x double prime is equal to 0.15 pi cosine of pi t times the derivative of the inside function pi. So the acceleration of the object, the second derivative of its displacement, is equal to 0.15 pi squared cosine of pi t. If we go ahead and use this with the number that it wants us to use, it wants to know what is going on with the acceleration at 1 second, so we can just plug in 1 second here. X double prime of 1 is equal to 0.15 pi squared times cosine of pi times 1. Cosine of pi is negative 1. So this equals negative 0.15 pi squared. So that's the acceleration at t equals 1 second, but it wants to know more about whether it's the minimum or the maximum in terms of acceleration. So we're actually going to have to take one more derivative here to find that out. So what we want to do is we just want to take the derivative one more time. So the derivative of cosine is negative sine, so we have negative 0.15 pi squared sine of pi t times the derivative of the inside function pi. We get negative 0.15 pi cubed sine of pi t. And then what we can use this for is making a sine diagram . We can make a sine diagram that shows where it changes direction. So pi 0, 0, 0, 2 pi, 0. Wait, no. T equals 1 and 2. So 1, 2. So we can see that t either is going to have a maximum or a minimum value at t equals, we can see that the acceleration is going to have either a maximum or a minimum value at t equals 1 second because the derivative of the acceleration is equal to 0, meaning it has a horizontal tangent with a slope of 0. So it means it's changing direction. So it does not matter that it is a local minimum because the question is actually asking for the magnitude of the acceleration. So since it is a turning point at all, that does mean that it has its maximum magnitude at that t value.